Next up, we're going to talk about the steps to solve an exact equation. And right now, this whole concept is probably feeling a little bit shaky, and that's okay. We're just going to have these steps up front so that you kind of have them in an easy to access place in your notes. And then we'll do some examples that will hopefully make it a bit more clear how this type of problem works. And something that I want you to kind of think about as we're going through this is that n, as we've written it, is kind of related to the derivative of f with respect to y, and m is kind of related to the derivative of f with respect to x. And f is something we haven't exactly defined, but it's going to be this function that gives us a relationship between our solution y and the variable it depends on x. But it's okay if that doesn't quite make sense yet. Like I said, this is a little bit of a weird section. But to start out, you want to make sure that you have an ODE in its differential form, where you're going to have m of xy times dx plus n of xy times dy equal to 0. And you'll want to check that it's exact. That means you take the derivative of the thing attached to x with respect to y, and you make sure it's the same as the derivative of the thing attached to y with respect to x. You're checking that the mixed derivatives of that function f, we don't really know what it is yet, but you want to make sure that they're the same. And there's going to be an extra step right here that we can take if it's not exact, but I'm going to leave that space blank until we get there. You just might want to make a little bit of room in your notes to have that as well. And then once you've checked that you have an exact equation, you can continue with the steps for actually using this method. And what that's going to be is you integrate m with respect to x. And so you're going to say that function f that we're not really sure what it is or what it means is the integral of m with respect to x. And then you're going to sort of bear in mind that f could depend on y. And so if you integrate m with respect to x, you're looking at sort of something that has ignored y up to now. And so there could be some unknown function of y that is inside of f that doesn't appear in m at all, because we said m is kind of like the derivative of f with respect to x. That's where that idea comes back again. So you're going to say, okay, well, I don't really know what that g of y was, but if I solve g equal to f minus integral of m dx, then I know that the derivative, g prime of y, would be the integral of f with respect to y minus the integral with respect to y of the integral of m dx. And then remember I said that, oh no, that eraser is way too big. We said that m is kind of like df dx, so n is kind of like df dy, even though we don't really know what f is. So if I want df dy right there, I can actually just put my n. So then you're going to say, okay, I know what the derivative g prime of y is, so I can go ahead and integrate to find g of y is equal to the integral with respect to y of all that stuff, n minus the derivative with respect to y of the integral of m with respect to x. Kind of confusing. I said there's a lot of integration in algebra here. All of that with respect to y. So I found g. That means that if I just kind of plug in I can find that f of xy from step 3 was the integral of m with respect to x, and now I just have to add g. So I add on the integral, n minus d dy, integral of m dx with respect to y. And then I'm going to set f of xy, which will just be sort of a bunch of things involving x's and y's, equal to c for some unknown constant. Remember, whenever we solve differential equations, we have unknown constants that tell us where those equations start. And then finally, you can just solve for y equal to some stuff, maybe. Similar to other methods, we might have that you can only get an implicit solution, in which case step 8 doesn't really happen. So those are the steps to solve an exact equation. And I know that they seem kind of out there right now. That's okay. We're just going to start an example that will kind of illustrate it. And I'm not sure that I can finish the example in the time that this video has left, and I don't want it cut across too. So I'm going to go ahead and stop here, and the next video is going to start your example.